how beautiful our world is. Look around. Everything you see was once nothing. But what was the beginning of it all? Hello, dear friends, and welcome to the AstroPlanetarium channel. Today, we would like to tell you about how our world and everything we know came into existence. What is the Big Bang, and what happened before it? Intrigued? Then get comfortable, relax, and let's begin. Let's go back a little in time, about 13.8 billion years ago. That's when it all started. A tiny point that expanded to incredible proportions. That's our young universe. But let's take it step by step. Inflation. Today, it is widely accepted that a period called inflation preceded the Big Bang. Trying to understand the essence of the early period of the universe's life involves dealing with such incredibly small and large numbers that our imagination struggles to grasp them. Let's try using an analogy to understand the process of inflation. Imagine a snow-covered mountain slope with various small objects scattered within: stones, branches, and pieces of ice. Someone at the top of the slope forms a small snowball and sets it rolling down the mountain. As it moves downward, the snowball grows in size as new layers of snow with all the embedded objects stick to it. And the larger the snowball gets, the faster it increases in size. Soon, the small snowball turns into a massive snowball. If the slope ends with a cliff, the snowball will hurtle into it with increasing speed. Upon reaching the bottom, the snowball will hit the cliff surface, and its components will scatter in all directions. By the way, some of the snowball's kinetic energy will heat the surrounding environment and the snow that scatters. Now let's describe the main points of the theory using the analogy provided. First and foremost, physicists had to introduce a hypothetical field. This field filled all of space. In our example, it's the snow on the slope. Due to random fluctuations, it took on different values in various spatial regions at different moments in time. Nothing significant happened until, by chance, a homogeneous configuration of this field larger than 10 to the power minus 27 centimeters was formed. This is our universe in its first moments of life. It is assumed that at such scales, the fundamental laws of physics that we know today are valid, allowing us to predict the system's further behavior. It turns out that just after this, a spatial region occupied by fluctuations begins to rapidly expand, and our field strives to assume a position where its energy is minimal. The snowball starts rolling. This expansion lasts only for 10 to the power minus 36 seconds, but it's enough time for our universe to grow to over 1 centimeter in size. Inflation ends when the inflaton field reaches the energy minimum. It can't fall any further. At this point, the accumulated kinetic energy turns into the energy of particles being born and scattered. In other words, the universe heats up. This moment is precisely what we call the Big Bang today. The mountain mentioned earlier may have a very complex relief, several different minima, valleys at the bottom, and various hills and bumps. Snowballs, future universes, are continuously born at the top of the mountain due to field fluctuations. Each snowball can roll into any of the minima, thus giving birth to its universe with specific parameters. Moreover, these universes can significantly differ from one another. The properties of our universe are astonishingly suited for the emergence of intelligent life. Other universes may have been less fortunate. The Big Bang, birth of the universe. After cosmic inflation came to an abrupt and still enigmatic end, more conventional explanations of the Big Bang theory gained prominence. A surge of matter and radiation, termed recombination, began filling the universe with baryonic matter. According to NASA, this remarkable event occurred within the first second after the universe's inception, when temperatures soared to an unimaginable 5.5 billion degrees Celsius. The cosmos brimmed with a vast array of fundamental particles, such as neutrons, electrons, and protons, the essential building blocks that would form all matter in the universe. This early soup remained invisible to the human eye as it could not retain visible light, NASA explains that free electrons would have caused light to scatter in the same way sunlight disperses off water droplets in clouds. However, as time progressed, these free electrons encountered nuclei, resulting in the formation of neutral atoms with equal positive and negative charges. This pivotal change allowed light to ignite, becoming visible around 380,000 years after the Big Bang. This visible light, often referred to as the afterglow of the Big Bang, is more precisely known as the cosmic microwave background. Initially predicted by Ralph Alpher and other scientists in 1948, it was accidentally discovered almost 2 decades later. Arno Penzias and Robert Wilson, conducting a radio receiver experiment in 1965 at Bell Telephone Laboratories in New Jersey, unexpectedly received higher temperatures than anticipated. Although they initially attributed the anomaly to pigeon droppings on the antenna, it persisted even after cleaning. Simultaneously, Robert Dickey's team at Princeton University sought evidence of relic radiation, and later realized that Penzias and Wilson had chanced upon it during their peculiar observations. Approximately 500 million years after the Big Bang, the first stars began to take shape, aided by dark matter, and simultaneously the first galaxies formed, gradually giving the universe the appearance we witness today. Present-day technologies still prevent astronomers from directly observing the birth of the universe. A substantial portion of our understanding of the Big Bang is derived from mathematical formulas and models. Nevertheless, humanity remains hopeful that one day we will peer into the distant past with absolute precision and unravel the remarkable story of our existence. Thank you for watching. If you enjoyed this video, don't forget to like and subscribe to the channel to stay updated on new and thrilling videos about the mysteries of our world. Feel free to share your suggestions in the comments regarding what you would like to see in future videos. Thank you, and see you in the next video.